This video is about experiments and observational studies. Specifically, we will discuss vocabulary, we will talk a little bit more about margin of error, and the intervals that we get from the margin of error. Explain whether each situation is an experiment or an observational study. Explain why. It'll be an experiment if the researcher is imposing some sort of a treatment on the subjects. In other words, if the researcher is deciding which subjects get which treatment, then it's an experiment. If the researcher is just showing up and recording what's already going on, and if the subjects themselves sort of sorted themselves into the treatment groups, then it's an observational study. So look at the first example. A marine biologist visits a certain beach in Florida every year and counts the number of eggs in sea turtle nests. Well, the biologist is not imposing some sort of a treatment on the sea turtles or the eggs or the nests. He's just showing up and recording what he sees. So this is definitely an observational study. The cafeteria manager of a high school wants to find out if high prices are keeping students from using the cafeteria. 50 students are chosen at random to receive half-price lunch passes every day for a month. The manager then records the number of passes used. Well, this is going to be an experiment because the lunch manager is deciding which students are getting the half-price lunches and which students are having to pay full price. I mean, he's using a random number generator, but still. The researcher is deciding who gets what treatment, and the researcher is imposing this treatment. He's not just observing what students are doing anyway, he's handing out these half-off passes. And that's going to make a difference. So that makes this an experiment. A survey reported that out of 5,500 people, 56% liked the movie Titanic. Assuming that the margin of error is plus or minus 1.3%, give an interval that is likely to contain the exact percent of people that liked the movie. Well, all we have to do is add and subtract the margin of error to the percentage that was given by the sample. So, well, normally we would calculate the margin of error, but we're given the margin of error. So all we're doing is, to find this interval, we're taking the sample mean, or in this case the sample percent, and we're going to subtract the margin of error to get the lower bound, and then we're going to take the sample response and we're going to add the margin of error. Alright, so that's all we're doing. So let me change colors. So the sample response was 56% like the movie. So we're going to start with that 56%, and we're going to subtract the margin of error, the 1.3%. That'll give us our lower bound, and then we'll take our 56% and we will add 1.3%. That will give us our upper bound. So if we do that, we get the interval that is likely to contain the true percentage of people, or the exact percentage of people, all the people who like the movie. It's likely to be in here somewhere. Okay, number 13. Why are double-blind medical experiments important? Well, when we talk about double-blind experiments, we're talking about experiments where the researcher that's conducting the experiment doesn't know which subjects are getting the treatment and which subjects are getting the placebo or whatever. The researcher doesn't know who's getting what treatment. That's one of the blinds in double blind. But of course, the subjects don't know either. That's the other blind. So neither the person conducting the experiment nor the subjects participating in the experiment know. And the reason why that's so important is because this helps us eliminate some of the sources of bias. Because when a researcher knows who's getting what treatment, they will often accidentally give little clues and behave differently towards the patient because they're expecting something to happen. And sometimes those clues that they give, and not on purpose, but they just give little clues because of their expectations. And that can have an effect on how the subjects behave. And of course, if the subjects knew whether or not they were getting a medicine or something, sometimes their expectations will change their responses to the treatment. So if nobody knows, then any changes, any responses, we can attribute directly to the treatments. Okay, so there I've just written up exactly what I just explained, so feel free to read that, but I'm going to move on. Number 14, a teacher wants to study the effects of classroom participation on a student's final grade. The control group is students who do not participate in class. The experimental group is students who do participate in class. What is the explanatory variable in this study? Look, when we talk about explanatory variable, we normally pair this with another word. We often talk about the explanatory variable as opposed to the response variable. Now, the explanatory variable is the possible cause. Not always, but if we think in terms of cause and effect, it will help you get into the right frame of mind to answer the question. So the explanatory variable is a possible cause. I mean, you're doing the experiment to find out if there's a relationship, so we don't know, but we're testing to see if the explanatory variable is some sort of a cause. And the response variable is the thing that we're trying to see how it is affected. All right, so cause and effect, explanatory variable, response variable. Okay, so when we talk about the two variables here are class participation and the student's final grade. The idea is, does participation affect final grade? So cause and effect. So that means participation is the explanatory variable and the final grade would be the response variable. Okay, number 15. Which types of sampling are almost always biased? Alright, it seems like we keep on coming back to the types of sampling. The two that are the most often biased are convenience sampling and self-selected. Convenience gives you a lot of bias because if you just pick a group in front of you, they're likely to have a lot in common that is going to make it different than the general population. For example, if my class might have all freshmen, and they're going to be shorter, and have a lot of other things that make them different than the school in general. So that's just one example. Also, self-selected, when people are deciding for themselves whether or not they're going to participate. Usually the people who feel the most strongly are going to be the ones who will bother filling out a survey. Another difference is people that are very busy are going to not take the opportunity to fill out a survey. And so a lot of times that's going to affect the results because you're mostly getting results from people who have extra time on their hands, and so that can create a lurking variable. Anyway, these are the two with the most bias. Alright, this lesson has been about experiments and observational studies. We talked about the differences between those two things. We went over some vocabulary, talked about margin of error, and the intervals that you can get using the margin of error.